Before we have learned about the concept for the magnetism and electromagnetism and the important words that meaning we have learned. So now we have discussed about magnetic field lines, magnetic flux, and the properties of magnetic lines of force. So there are two types of magnets, that is natural magnet and artificial magnet. So the natural magnets exist in the natural. So these natural magnets are deposited in the what is this rock, sand, and various places in the world. So the natural magnets can't be destroyed. These are the magnetic property in the natural magnets is permanent. The strongest natural magnet is lodestone magnetite. So lodestone magnetite is the strongest natural magnet. So this lodestone magnet is used to make the compasses. So these compasses used to find out the way. Olden days, the ships were used in the compasses. So the next one is artificial magnets. These are the man-made magnets. These magnets is available in the shops. These are the brakes. But the natural magnets never can destroy. But the artificial magnets is easy to broke. So the first one is magnetic field. So this is denoted by a B and the unit is Tesla. Already we know that what is a magnetic field. The magnetic field is the region around the magnet where it is magnetic influence can be felt. That is magnetic field. Put a magnet on the tables and put a clips. That is a paper clips. Slowly move to the what is this? Magnet. Slowly move to the magnet nearby the paper clips. Some of the point the paper clips are attracted to the magnet. So the magnet around the some of the force, that is magnetic force. So the magnetic force is directed, that is magnetic field. That is magnetic field is the region around the magnet where it is magnetic influence can be felt. So the magnetic field is denoted by what is this B? The unit is Tesla. So these are the pictures, that is compasses. The compass showing that magnetic field. So direction of the magnetic field. So north to south pole. The magnetic field is north to south pole. So in this magnetic field penetrates through the all kinds of materials. The next one is magnetic field lines. So the definition is the magnetic field line is defined as a curve drawn in the magnetic field in such a way that the tangent to the curve at any point gives the direction of the magnetic field. So you see that diagrams, red color point marks the curve drawn in the tangent. So magnetic field lines means that the magnetic field also called as what is this? Closed-ended continuous curves. And the curve என்ன பண்ணிருக்கோம் tangent point நம்ம mark பண்ணிருக்கோம். So அந்த அந்த tangent point தான் நம்ம என்னன்னு சொல்றோம். அது வந்து என்ன நமக்கு வந்து அதை find out பண்ணி கொடுக்கும். Direction of the magnetic field. A, B, C. These are the tangent curve. So this gives the what is the direction of the magnetic field. இந்த magnetic field line வந்து எங்க வந்து நம்மளால draw பண்ண முடியும்? Magnetic field இருக்கிற பிளேஸ்ல வந்து நம்ம ட்ரா பண்ண முடியும். ஸோ மேக்னெட்டை வந்து ஒரு பிளேஸ்ல வச்சோன்னா அதை சுற்றி என்ன இருக்கும்? மேக்னெட்டிக் ஃபீல்டு இருக்கும். அந்த மேக்னெட் எது வரைக்கும் மேக்னெட்டிக் ஃபீல்டு இருக்கோ அது வரைக்கும் தான் நம்மளால என்ன பண்ண முடியும்? மேக்னெட்டிக் ஃபீல்ட் லைன் ட்ரா பண்ண முடியும். So this magnetic field line starts with North Pole and ends with South Pole. South Pole. All of you know that the direction of the magnetic field is the arrow mark indicates that the direction of the magnetic field, that is north to south. So the magnetic field is at a point, that is any point, that is A, B, C or any point. It is tangential to the magnetic field lines. So the magnetic field at a point is tangential to the magnetic field lines. So magnetic field lines means that the curve drawn in the magnetic field. Next, the magnetic field lines start to North Pole and South Pole. The magnetic field at any point is tangential to the what is this magnetic field lines. These are the magnetic field lines. The next one is magnetic flux. The definition is magnetic flux means the number of magnetic field lines passing through a given area. So it is denoted by phi and the unit is Weber, that is WV. So we give you some area. So that area, what are the magnetic field lines passing through a given area? That is magnetic flux. What are the number of magnetic field lines passing through a given area? That is what is this magnetic flux. So ஒரு குறிப்பிட்ட ஏரியாக்குள்ள எவ்வளவு மேக்னெட்டிக் ஃபீல்ட் லைன் பாஸ் ஆகுது அப்படின்னு சொல்லி அதை மெஷர் பண்றத நம்ம என்னன்னு சொல்றோம்? மேக்னெட்டிக் ஃப்ளக்ஸ். The number of magnetic field lines crossing unique area kept normal to the direction of field lines, that is called magnetic flux density. Its unit is Weber per meter square. So the number of magnetic field lines crossing unit area kept normal to the direction of field lines is called magnetic flux density. So same for the magnetic flux. The magnetic flux, that is number of magnetic field field lines passing through a given area, but the number of magnetic field lines crossing a unit area, that is given area. அதுல வந்து கொடுத்திருக்கு முழு பிளேஸ்லயும் எவ்வளவு நம்பர் ஆஃப் மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் பாஸ் ஆகுது அப்படின்னு சொல்லிட்டு மெஷர் பண்ணா மேக்னெட்டிக் ஃப்ளக்ஸ். பட் தி யூனிட் ஏரியா அதுக்குள்ள எவ்வளவு மேக்னெட்டிக் ஃபீல்டு லைன்ஸ் கிராஸ் ஆகுது அப்படின்னு சொல்லிட்டு மெஷர் பண்றத நம்ம என்ன சொல்றோம், மேக்னெட்டிக் ஃப்ளக்ஸ் டென்சிட்டி. The unit is Weber per meter square. Weber per meter square. So these are the magnetic flux density, not a magnetic flux, a magnetic flux density. So these are the less flux density and more flux densities. So the less number of magnetic field lines crossing a unit area, that is a less flux density, and more number of magnetic field lines crossing a unit area, that is more flux density. So the less number of magnetic field crossing a unit area and more number of magnetic field lines crossing a unit area kept normal to the direction of the field lines, that is more flux density. The next one is properties of magnetic lines of force. So இது வரைக்கும் நம்ம பார்த்தது வந்து என்ன பண்ணலாம், properties of magnetic lines of force find out பண்ணலாம். So the first property is magnetic lines of force are closed continuous curves extending through the body of the magnet. So the magnetic lines of force are the continuous curve. So நீங்க பிக்சரை பார்த்தாலே உங்களுக்கு தெரியும் அந்த மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் எப்பவுமே எப்படி இருக்கும், கர்வா தான் இருக்கும். ஓகேவா, அது மட்டும் இல்லாம அது க்ளோஸ்டா வேற இருக்கும். அது எது வரைக்கும் எக்ஸ்டெண்ட் ஆகும்னா மேக்னெட்டிக் ஃபீல்ட் எது வரைக்கும் இருக்குமோ அது வரைக்கும் தான் என்ன இருக்கும், மேக்னெட்டிக் ஃபீல்ட் லைன்ஸ் வந்து இருக்கும். ஓகேவா. ஸோ நெக்ஸ்ட் ஒன் இஸ் மேக்னெட்டிக் லைன்ஸ் ஆஃப் ஃபோர்ஸ் ஸ்டார்ட் ஃப்ரம் தி நார்த் போல் டு எண்ட் அட் தி சவுத் போல். ஸோ the magnetic lines of force start to the what is this north to south. நார்த்ல ஸ்டார்ட் ஆகி எங்க முடியும், சவுத் போல தான் முடியும். So these magnetic lines of force never intersect because this is the what is this curve lines, so does not intersect. They will be maximum at the poles than at the equator. இது மிட் பாயிண்ட்ல இதோட ஃபோர்ஸ் அதிகமா இருக்கிறத விட எங்க இருக்கும், நார்த் அண்ட் சவுத் போல தான் அதோடைய ஃபோர்ஸ் வந்து எப்படி இருக்கும், அதிகமா இருக்கும். The next point is the tangent drawn at any point on the curved lines gives the direction of the magnetic field. So here what is this tangent by this gives to the direction of the magnetic field. Already we seen that. So these are the properties of the magnetic lines of force. There are 5 points. These are the important questions. Okay. So in this class we have discussed about what a magnetic field, magnetic field lines, and magnetic flux, magnetic flux density, and the properties of magnetic lines of force. Magnetic flux means that the region around the magnet where its magnetic influences can be felt. So the magnetic field is denoted by a B. The unit is Tesla. The next one is magnetic field lines. So it is defined as the curve drawn in the magnetic field in such a way that the tangent to the curve at any point gives the direction of the magnetic field. So the magnetic field is start to north to south pole. So the arrow mark indicates that the magnetic field direction. The next one is magnetic flux. The number of magnetic field lines crossing through a given area, that is magnetic flux. This is denoted by phi, and the unit is Weber. So next one is number of magnetic field lines crossing a unit area, that is magnetic flux density. There are two types, less flux density and more flux density. So the less number of magnetic field lines crossing unit area, that is less flux density, and more number of magnetic field lines crossing unit area, that is more flux density. So this unit is Weber per meter square, that is magnetic flux density unit is Weber per meter square. The next one is properties of magnetic length of force. There are 5 properties. First one is closed continuous curves and extending to the body of the magnet. Start from north to and end to south pole. And these forces never intersect. These forces maximum at the poles than at the equator. So tangent drawn at any point, the curved lines give the direction of the magnetic field. Thank you.